Hello friends, good morning, good afternoon, good evening, no matter whatever the time you are seeing this video. Okay, so welcome to average classes. Yeah, you heard it right, it's average classes. But anyway, we'll do it. Come on. So, say this. Today, it's going to be a very important topic. Okay, it's viscosity. Viscosity is the king or hero of the fluid mechanics. So, थोड़ा patience रखो, learn it carefully, learn it detailedly. Okay. So many of questions you'll find in whether you write AE, AEE, GATE, PSU, CISRO, but no matter whatever the exam you write, there will be questions from viscosity. ठीक है? तो सारी viscosity चीज है क्या? What is this viscosity? See, what happens is when your fluid is moving, fluid in motion, important. Okay, when the fluid is moving, what happens? In the adjacent layer, they try to restrict each other's movement. क्या adjacent sides, adjacent layers, tries to restrict each other's movement. Okay, this phenomenon, this property, it's only known as viscosity. So sir, is it required the fluid should be in motion? Yes, the fluid has to be in motion, then only it will resist the motion. Understood? It's like friction. देखो, yes and okay. So is there any friction here? Sir, maybe होगा property, लेकिन मुझे दिख नहीं रहा है. Correct. But what if it's moving? When it's moving, then only I'm getting a friction here. That's in the case of solid. In liquid, it is what? Viscosity. So, what's the viscosity? It's a property by virtue of which a fluid offers, resistance, to the movement of one layer of fluid over the adjacent layer when in motion. समझ गए आप? Okay? यानी कि ये मेरा पानी है, ठीक है? Now it is what? Static. Rest में सर इसमें viscosity तो है ही नहीं है, अंदर है, hidden है. When I throw it, when the fluid will start flowing, after some time it will come to rest. ठीक है? Okay, there are so many other factors, but what basically happens is that each layer will try and resist the adjacent layer, which is known as your fluid viscosity. Okay? So, see, primarily it is because of the cohesion and your momentum between the fluid layers. Now, see. Listen this. Your fluid, when I am talking about liquid, okay, remember always in liquid, cohesive forces dominates the molecular momentum forces. किसमें? Liquid में. Okay. In case of gases क्या होता है? What happens in gases? Ulta. The molecular momentum forces dominates the cohesive force. Understood? What happens in a liquid? The cohesive force. Sir, cohesive force क्या है? It's the force of attraction between the particles of the same material, same component. Okay, water, the molecules of water, what are the forces they are? Force of attraction they are having, cohesive forces. If it is between water and a wall, adhesive force. Okay, water and a glass, adhesive force. Mercury and a glass, adhesive force. Mercury, cohesive force. Water, cohesive force. Understood, right? Molecular momentum force. देखो भाई, तुम्हारे gases है ना, they are like backbenchers. सबसे ज़्यादा मस्तीखोर. Okay, too much. So if you keep a gas inside a container and you will close it, what will happen? They'll be vibrating. They'll be moving around. They'll be colliding with each other. They will be transferring their kinetic energy to others. Okay, that only you call it as a molecular momentum force. So in gases, the molecular momentum force dominates the cohesive force. Okay, pause the video and note it down. So what happens is, once this viscosity for a prolonged period of time, you say, ultimately we consider it as a shear stress and we take it as a shear stress. Okay? So today's topic is going to be viscosity and Newton's law of viscosity, which is very, very, very important. Okay, bhai? Samajh gaye? Now I'll erase. Okay. So viscosity, what you understood? Sir, it is a property. Yes, it's a property of fluid. When it is in motion, the adjacent layer tries and resist the movement of the other layer. Correct? Yes. This means viscosity acts in between the layers, between the adjacent layers. Okay, now let's try and understand this little better way. So we have a surface here. Okay, we have a surface here. Now, what will be the velocity of the liquid which is directly and which is on the surface? What will be the velocity? This surface is stationary. So what will be the velocity of the fluid touching the boundary? 0, because it is velocity of the boundary is 0 and the fluid which is touching the boundary velocity is 0. This only we have studied no slip condition. Yes or no? हाँ भाई, बेसिक्स में हमने पढ़ा है इंट्रोडक्शन टू फ्लूइड मैकेनिक्स लेक्चर 1. We have studied no slip condition. What is your no slip condition? The velocity of the fluid adjacent to the boundary has the velocity of the solid boundary itself. So if this boundary, this surface is stationary, so your fluid, what is the velocity of fluid here? 0. Okay. So what will happen? The next fluid particle, let us say it is having a velocity u, little more than this, then little more, then again more, then there will be a time or there will be a length or there will be a depth at which this velocity of this particle will be around 99.99% of the free stream velocity. Sir, free stream velocity क्या है? ये तुम्हारा सरफेस है, मान लो ये तुम्हारा सरफेस है, ठीक है. ये सरफेस के ऊपर क्या छोड़ दिया तुमने? ऐसे पानी या फिर ऐसे लिक्विड ऐसे डाल दिया, ठीक है. सो दैट लिक्विड व्हेन इट इज एंटरिंग द सरफेस, लेट अस से it is entering at a velocity of u infinity, which we call free stream velocity, which we call it as what? U free stream velocity. This enters as soon as it touches the first layer which touches the surface, its velocity becomes 0. Then this one resists viscosity property, because of the property of viscosity it resists this one. अब ये वाला इसको resist करेगा. The third one will resist the fourth one again will resist the fifth one. So there will be a resistance of motion between the fluid particles, adjacent fluid particles, as the fluid is moving. There will be a time, okay, where the velocity of the fluid will be almost equal to the free stream velocity. Detailing about this we will study in boundary layer. Now you understood. So what from this we come to know is, sir, there is a difference in velocity. Is it? Yes, it is. See, this one velocity is suppose 99% of the free stream velocity. The velocity below that is less than that. Sir, is it correct? 101% correct. Pakka correct. There is a velocity difference is there. As you go down, there is a change in velocity with respect to the depth. That's only we call velocity gradient. That's only what you call velocity gradient. The change in velocity as with respect to the change in the depth. Understood? Okay. So sir, what you are trying to prove here? What I am trying to prove here is, let us say the velocity of this point is u. Velocity at this point is u. So definitely its adjacent particle, see I am considering this as adjacent particles. Okay, these two are 1, 2, 3, 4 like that particle. Okay, there are so many particles. The top portion is 99.99% of the free stream velocity. Okay, so this is u. Then what will be this velocity? How do we know, sir? You don't know, but you can definitely tell me greater than u or less than u. Sir, greater than u, because you told as it comes down velocity decreases, hence when it goes up the velocity increases. Okay, हम ये फंडा फिक्स कर लो, no problem, do it. So it will be more, so it is going to be u plus du. ठीक है, they are very adjacent. U and u plus du, these two particles are very adjacent. So let me take this depth as dy. So what is the total depth you are taking? Total depth is, let us say, y. For the time being, this depth I am taking how much? dy. ठीक है. Now this thing only I will represent here. ठीक है. See this. What I am writing? ऐसा है. हाँ सर ऐसा है. यहाँ पर you have velocity u. Here you have some velocity u plus du. Okay. ऐसा गया है. And so these two are very adjacent, very near to each other. So instead of drawing something like this, I will draw this as a straight line. Okay, it's almost a straight line. Okay, let's say the angle between them is d theta. What is the angle between them? D theta. How much is this? dy. So how much distance they have covered, sir, in time interval dt? In time interval dt is the time interval. How much distance they have covered? Come on, sir, very simple. You have velocity equal to distance by time. This implies this or displacement equal to velocity to time. So what is the velocity here? U. So how much distance it has traveled? U dt. Okay. Similarly, this particular layer, how much distance it has traveled? U plus du into dt. That means this is du dt. This particular area is u dt. This much is u dt. This much is du dt. Okay. थोड़ा zoom कर लेना. If it is not visible, I think it's visible. ठीक है, du dt. Okay. Now let us see about this triangle. ये जो triangle है ना, दिख रहा है ये triangle? ये this triangle. Here it is du dt. This angle is d theta. Okay, and this is correct. So what will be your tan d theta? Tan डाल दो इसमें. Tan opposite by adjacent. That is du dt by dy. For small angle d theta, what is tan d theta? Nearly equal to d theta only. Correct. So what I am getting from here? D theta is equal to du into dt by dy. This implies d theta by dt is equal to du by dy. Bolo ha. Okay, did you guys understand? So समझ में आया ये कैसे हुआ? नहीं सर, फिर से एक्सप्लेन. ओके भाई, फिर से एक्सप्लेन करते हैं. देखो, this is a surface, a plate. Fluid is flowing in this plate. From our no slip condition, the velocity of the fluid adjacent to the boundary has the velocity of the solid boundary itself, and the velocity here will be zero. But slowly the velocity is increasing. While the velocity is increasing, its adjacent layer are applying a resistive force and try to resist the movement of the fluid. Hence this particular one will be resisting 2, 2 will be resisting 3, 3 will be resisting 4, 4 will be resisting 5. This property only we called it as what? Viscosity of the fluid. Okay, when it is in motion. Hence, so then we took out the first particle, we took here u. We went to the next particle. Obviously, its velocity is more than the previous. It is u plus du. Let us say these are at a depth of dy. This only I have drawn here. ठीक है, क्या किया? ये है तुम्हारा पार्टिकल, ये है अदर पार्टिकल. दिस इज व्हाट du. What will be this distance? Sir, velocity equal to distance, displacement by time, and displacement equal to velocity into time. समझ रहे हो ना? Displacement equal to your velocity into time. So this is your u dt. This will be, what is the velocity? U plus du into dt. That is u dt plus du dt. Now I am trying to read this. Hence I have drawn the diagram here. Correct. What is your dy? Is the depth here. D theta is the angular displacement. Du dt the distance traveled. So if I take the tan theta here, it is what? Opposite by adjacent. What is your opposite? Tan d theta. Du dt divided by dy. So for small angle d theta, tan d theta equal to d theta. So d theta equal to du dt by dy. Hence d theta by dt equal to du by dy. Sir, इतना सब क्यों पढ़ा रहे हैं? Why you are teaching all these things? Because next I am going to teach is your what? Newton's law of viscosity. Newton's law of viscosity, this becomes very important. Sir, बोल तो दो ये d theta by dt क्या? See, remember, you have anything divided by time is rate. ठीक है? If a quantity or if any substance is varies with respect to time, we call it rate. ठीक है? Similarly, if it varies with respect to length, we call it as gradient. तो यहाँ पर देख सकते हो dy नीचे है यानी कि ग्रेडियंट ऑफ वेलोसिटी. सर व्हाट इज वेलोसिटी ग्रेडियंट? हियर ओनली आई टोल्ड ना, as you are moving down or moving up the velocity changes. Here the velocity is maximum, subsequently as the depth increases your velocity decreases and velocity becomes zero at the surface of the boundary itself. Okay, so as you are moving down, as your length or depth of immersion is your, what, increasing, your velocity is differing. So this behavior of the velocity with respect to the depth, we call it as a velocity gradient. ठीक है? d theta by dt, you can call it as an angular displacement. d theta is the angular displacement, dt is the t. So we call it a rate of angular deformation. Rate of angular deformation. If you recall your strength of material, we also name it as what? Shear strain. We also define it as shear strain. How the shear strain is? Angular deformation only, isn't it? So here d theta by dt, we call it as what? What we call? Rate of shear strain. अगर भाई साहब, if you didn't write this rate, it's gone. Question it will come. Okay. So remember, it is rate of shear strain or rate of what? Angular deformation or rate of angular deformation. Understood? समझ गए? ठीक है? What is your du by dy? What is your du by dy, sir? Du by dy is nothing but velocity gradient. What is du by dy? It's nothing but your velocity gradient. Understood? समझ गए? ठीक है ना? Now, कभी-कभी क्या होता है? There are some empirical experiments. People have done some empirical experiments. Okay, that I will come to later. We can study now also. Okay, some empirical experiments they have done. What they have done? Okay, let us say there is you have a plate. How many plates are here? 2 plates are here. What is the area? A. What is the depth between them? Capital Y. Let us say Y. Y is the distance between these 2 plates. यहाँ से यहाँ. समझ रहे हो ना plates? Okay. So let us say F is the shear force and V is the velocity. V लो, U लो, your power. This only how we represent, बोलो हम इसको कैसे represent करते हैं? Like this. We study ना. This is one plate. There is another fixed plate. Okay. This is your fixed plate. This is your movable plate. ठीक है? And you have fluid in between them. You have fluid in between them. ठीक है? And the top plate is moving at a velocity of v. Constant velocity of v. Constant velocity of v. What is the area, cross-sectional area of this both plates? A. What is the cross-sectional area of this both the plates? A. That means what is the area coming in contact with the liquid surface? A. Okay. What is the velocity here? V of the moving. The constant velocity v, it is moving. So in order to move the velocity v, you need a force or not? You are pulling it. You are pulling it, and this particular plate is moving at a velocity v. Let's say that force is F. So this force is which kind of force? Shear force. Why shear? It's a tangential force. When your plate is moving, the liquid is applying a force of F on the plate. That is the shear force applied by the liquid on the plate itself. Okay? So that is your F. So I can say F is the shear force required to maintain the plate moving at a velocity of v. समझ में आ गया? So by some, I can, इसको आप confuse मत हो गए ना? ऐसे you just separate it, you just separate it. यहाँ तक ऐसे सेपरेट करो, इसको इक्वेशन 1 दे दो, ठीक है, जस्ट सेपरेट इट, कंफ्यूज मत करना, ठीक है. सो इट इज moving at a velocity v. What is the shear force on the plate by the fluid F? So this is where your empirical relation, empirical experiment, they have conducted some experiment. From that what you come to know is the shear force is nothing but it came directly proportional to a, okay, more the force, more the area, more the shear force is being applied. Okay, this shear force is also directly proportional to v. If you want to pull it at a higher velocity, if you have to apply more force, or the force applied on the plate by the liquid will be, or by the fluid will be obviously more. समझ गए? Okay. Similarly, what it says, your F, okay, is inversely proportional to your y depth. जितना ये ज्यादा होगा उतना कम हो रहा है. Okay. Now these are the your experimental results what have been obtained. So now combining all three, what you will get, F is directly proportional to, you know, A B by Y, or F is proportional to, F by A is proportional to B by Y. समझ गए? Now what is this shear force per area? Shear stress. What is that? What is this shear force per area? Is nothing but you write shear stress is directly proportional to your V by Y, where V is the velocity at which the plate is moving, Y is the depth, or the perpendicular distance, between the two plates, at any given point. Understood? But these results, these all are only valid. Remember, because we have written V, I have took the direct absolute velocity, I have took the direct depth. These are only valid when your velocity profile is linear. Here we have seen a velocity profile different, isn't it? This case is only valid when your velocity profile is linear, like this. Okay? When the velocity profile is linear, this is V, this is Y, then only it is valid. We can prove it, we'll prove it after some time. Okay? Then only this is valid. समझ में आ गया? Okay, so we got this 2, we came 1. From here the Newton's law of viscosity comes. Okay, what Newton said? Newton told the shear stress, the shear stress required to maintain the fluid flow. What Newton said? The shear stress required to maintain the fluid flow is proportional to the velocity gradient, or rate of angular deformation, or rate of shear strain. If you are not writing this, your mark on rate if you are not asking. So questions they constantly, so note it down, pause the video and note it down. I have to erase. Okay, so what Newton's law of viscosity said? The shear stress required to maintain the fluid flow is directly proportional to rate of shear strain, or rate of angular deformation, or velocity gradient. Newton's law of viscosity. What did it say? The shear stress required to maintain the fluid flow is directly proportional to, बहुत क्वेश्चन आता है न्यूटन्स लॉ ऑफ विस्कोसिटी से, so many questions come. Proportional to rate, और रेट भूल मत जाना, एग्जाम रॉन्ग हो जाएगा. shear strain or rate of angular deformation, or velocity gradient. This exactly, this only we have just studied before. Tau is proportional to v by y हमने पढ़ा था ना through experimental results. That is, your tau is proportional to d theta by dt. This is your rate of shear strength. This implies tau is also d theta by dt equal to du by dy. Yes or no? Now, if I remove the proportionality symbol, I have to multiply with a constant. I have to multiply with a constant, and I cannot just multiply some random constant. I have to multiply such a constant which shows the variation between these two. Correct? Why there is a velocity gradient? Because of viscosity, because of resistance. And I told you, when the viscosity prolonged time, the third point of viscosity I told you, after some time when the continuous viscosity is there, that only we consider as shear stress. Initially starting of the video I have written viscosity definition 1, 2, third point I have written third point. Okay, so tau is equal to mu du by dy. Tau is equal to mu du by dy. समझ में आ गया? What is mu here? This is very very important. Okay, this is very important. I will tell you what is very very important. So tau equal to mu du by dy. What is your tau? Shear stress. So where mu is the absolute viscosity. What? Mu is the absolute viscosity, or we call proportionality constant. Proportionality constant. So what you understood? Tau equal to mu du by dy. ठीक है? Tau equal to mu du by dy. Now, if you remember, क्या सर हमको क्या याद रखना है, कितना पढ़ा रहे हो सर? नहीं भाई, विस्कोसिटी इज वेरी इंपॉर्टेंट, आपको समझना पड़ेगा. नो अदर एस्केप फ्रॉम दिस. ठीक है? बट म्यू इज द एब्सोल्यूट विस्कोसिटी और प्रोपोर्शनलिटी कांस्टेंट. नाउ आई टोल्ड यू व्हाट, व्हेन द वेलोसिटी प्रोफाइल इज लीनियर, व्हेन द वेलोसिटी प्रोफाइल इज लीनियर, जस्ट वी ड्रॉ द ग्राफ, राइट? लीनियर, दैट इज, or the thickness of the fluid is very small thickness. We have drawn this diagram now. Just before only we have drawn this diagram. Remember, empirical formula बोला था. This is by area, moving force. It's moving at a velocity v. The force required is f. Okay. In such cases, what will happen? Your velocity profile is becoming linear like this. This is the depth. The velocity moving system velocity is v. This is becoming y ले लो or h ले लो sometimes. Okay, your thought. ठीक है? So let us say at some height dy, what is your velocity? Let the velocity be du. Now take from similar triangles. From similar triangles, you will get du by dy is equal to v by y or v by h. आपको जो लिखना है लिखो. Okay, put these things here. Okay, now if you apply tau here, what will got? Tau is equal to mu v by y. This is what gate asks. Tau equal to mu v by y. समझ में आ गया? Now, what is tau? सर यहाँ पर आपने फोर्स पर एरिया लिखा है. Yes, F by A is equal to mu v by y. This implies mu is equal to क्या हुआ? F by A into y by v. Or mu is equal to tau into y by v. Mu is equal to tau into y by v. So what you come to know here? What is the viscosity? What's the definition of viscosity? It is the shear stress required. It is the shear stress. So viscosity may be defined as, it's the shear stress required to produce unit velocity gradient. It is the shear stress required to produce unit velocity gradient. सर इतना सारा बोल दिया, ये सब इम्पोर्टेंट है कि हाँ बेटा आपको ये याद रखना ही रखना है. You have to remember this. You have to remember this. ठीक है? So many questions we get from there. Newton's law of viscosity is so many things we got from there. So now you know the mu is in terms of force. Yes or no? We are defining the viscosity in terms of force. Hence, this is also known as, because we are defining this in terms of force, we also call it as what? Dynamic viscosity. As we also define it in terms of forces, hence this absolute viscosity or the proportionality constant or the viscosity constant is also known as your dynamic viscosity. Sir, थोड़ा और एक बार रिवीजन कर लो. What is Newton's law of viscosity? Come on. What Newton's law of viscosity said? The shear stress required to maintain the fluid flow is directly proportional to rate of shear strain or rate of velocity gradient or proportional to or rate of angular deformation or proportional to velocity gradient itself. Okay, not rate of velocity gradient. Rate of shear strain or rate of angular deformation and velocity gradient. What? The shear stress. So that is tau is proportional to d theta by dt. But we already proved d theta by dt is nothing but du by dy. So tau is proportional to du by dy. Whenever you take the proportionality constant, whenever you take the proportional symbol out, you have to multiply with a constant. That constant should relate the, relate to both the left hand side and right hand side. That we have to mu du by dy, where mu is the absolute viscosity or proportionality constant. Then we took a case. The case is velocity profile, and when the thickness is very small. What we come across? Now there are two plates. The two plates are separated by a distance y, and the cross sectional area of the plates are a. Okay, and the upper plate is moving at a velocity v, and the force required to maintain the velocity is f. And the distance between them is very less. Then only I'll get a linear velocity profile. For a linear velocity profile, this is y, v. Let us take at some distance dy, the velocity be du. From similar triangle, du by dy equal to v by y or v by h. Putting this value here, tau mu du by dy, here tau mu v by y. Now tau is nothing but force per area, shear force per area, F by A equal to mu v by y. From this equation, mu equal to F by A into y by v, or mu equal to tau y by v. That means what is the mu? What is mu viscosity? It's the shear stress required to produce unit velocity gradient. It's the shear stress required to produce unit velocity gradient. As this mu term we are expressing in terms of F, force, and this is also known as your dynamic viscosity. Okay, dynamic viscosity. So many, लिख लिया? Note it down. Okay, pause the